Okay, hello everybody. So today we're going to continue our discussion in Chapter 6, Section 5, and I'm going to show you another Okay, hello everybody. So today we're going to continue our discussion in Chapter 6, Section 5, and I'm going to show you a few more examples as to where you might be using these systems of linear equations. So let's get started. The first example I'm going to show you here is number 5 from the notes packet, and it says the sum of two numbers is 41, and their difference is 9, and they want you to figure out what the two numbers are. So what you would do is you would begin these just like you would do for the other ones, where you would start by defining your variables. So x would be the first number, and then we can say y is going to be the second number. And then we need to look within the problem to actually come up with the equations that we would write. So it says the sum of two numbers is 41. Recall that the word sum means to add. So if you were to add x plus y, that will equal 41. Now the second part says, and their difference is 9. And also recall that the word difference means to subtract. So then that means x minus y would be 9. So there you go. We've got the two variables defined. We've got the two equations written. And now it's just a matter of solving these. Really, however way you would prefer to do it. I believe that the easiest way would be elimination because both of these are in standard form. So you can see the x's and the y's are both on the same side. And you can also see that the variables y are the same, but they're opposites, which is great. Because if we were to take these two equations and add them up, just like this, the x's would turn into 2x because 1x plus 1x is 2x. But the y's would cancel. Y plus negative y is 0. That goes away. And then we're left with 41 plus 9, which would be 50. Okay, and then to finish solving this, we would simply divide both sides by 2, and we would get x equals 25. Now, once I have the x value, I do still need to solve for the y. I'm going to go ahead and use the first equation, which is x plus y equals 41. In place of the x, I'm going to write 25 since we just solved for that. And then I'm going to subtract 25 from both sides. And I'm going to get y equals 16. And so there you go, guys. That's how you solve that one. So the two numbers that we would have would be x would be 25 and y would be 16. The next example I'm going to show you is number 6. It is also very similar to the last one. It's talking about a couple of numbers. It says the sum of two numbers is negative 10. It says negative 3 times the first number minus the second number equals 2. Find the numbers. And so what we need to do is the same as the last one. We're going to go ahead and define our variables first. So x is going to be the first number. Y is going to be the second number. And when I go to write my equations, it says the sum of the two numbers is negative 10, which means when we add the two up, x plus y, it equals negative 10. Now, the second equation is going to be a little harder. It says negative 3 times the first number. So I'm going to write that. Negative 3 times the first number minus the second number and equals 2. So negative 3 times the first number minus the second number equals 2. So that is going to be negative 3x minus y equals 2. So once again, you can see we end up with two equations that are both in standard form. And when you have both in standard form, I think that the most straightforward way to do this is usually through elimination. And this problem is going to prove that. You can see that the y values it's the same y, but they're opposite signs, which is great because then what we can simply do is just add those two things up like this. So I'm going to have x plus negative 3x, which gives me negative 2x. And then I have y plus negative y, which is 0. Those cancel. That's good. That's what we want to happen with elimination. The last one, it says negative 10 plus 2, which would give me negative 8. Now from there, it's a one-step equation. We simply divide both sides by negative 2, and x equals 4. Okay. Once I have x equals 4, I'm going to go ahead and take that value and plug it back in. It doesn't matter which equation. Sometimes it looks like there is one that might be a little easier. In this case, the first one I think is a little bit easier. So we're going to go ahead and take x plus y equals negative 10. And I'm going to put 4 in for x. Then I'm going to subtract both sides by 4. Y equals negative 14. And there are our two numbers. X is 4 and y is negative 14. The number 7 is very similar to the last two that I just did. So I'm actually going to skip number 7, but I am going to do number 8 with you here. And so what number 8 says, it says Joe and Adam each want to buy a video game. Joe has $14 and saves $10 a week. Adam has $26 and saves $7 a week. In how many weeks will they have the same amount? So this one is definitely a little bit different than the last two. One, because it's a word problem and we're talking about two friends that are trying to save money and they want to find out when they have the same amount of money. But two, how the equations are set up are going to be a little bit different than in the previous couple of problems that we've done. So the first thing that we need to determine is what our variables will be. Okay, so x is going to be the number of weeks. Actually, that's not true. X is going to be the number of weeks. So we're going to go ahead and define x as the number of weeks. Y is going to be the total amount of money. So x is the number of weeks, y is the total amount of money. Once we know those two things, we can begin to form the equations. So it says Joe and Adam each want to buy a video game. Joe has 14 already, and then he saves $10 per week. So I'm not sure if you might recognize this or not, but this is a perfect example of y equals mx plus b. Now remember, for slope-intercept form, b is your beginning amount. That's how much you start with. And then the m is your reoccurring amount. It's an amount that shows up more than once. It comes, like in this case, every week. So in this first equation for Joe, it says Joe has $14. So he's starting with 14, and then he's saving 10 a week. So the $10 is a per week reoccurring amount. So remember, B is the starting amount, and M is the reoccurring amount. So in this case, the equation then for Joe is going to be y equals 10x plus 14. Now, in the similar way, we're going to come up with an equation for Adam. And you can see Adam started with $26, and then he saves $7 per week. So that's going to be the 26 is your beginning amount, and then the $7 per week is the reoccurring amount. So that'll be your M. So your second equation is y equals 7x plus 26. Now, once we have the two equations, you can see these are both in slope-intercept form. So it would actually be easier to use substitution to solve this. So to use substitution, we're simply going to set both equations equal to one another. So 10x plus 14 is equal to 7x plus 26. I'm going to subtract 7x from both sides. I get 3x plus 14 equals 26. I'm going to go ahead and subtract 14 from both sides. 3x is equal to 12. And last, I'm going to divide by 3. And x equals 4. Okay. Now, once I have what x is equal to, I would take that x value and plug it in. It doesn't matter which equation. I think I'm going to use the first. Y equals 10x plus 14. So the 10 is going to multiply the x, which in this case turns into 4 from what we solved. That turns into 40 plus 14, which gives me 54. Now, what do these numbers mean within the context of the problem? Well, we can refer back to our defined variables to know exactly what this means. So if you look at the first one, x is the number of weeks. So in this case, it's going to take 4 weeks. And then y is the total amount of money. So after 4 weeks, they will both have $54. So there you go, guys. Hopefully that made sense for you. And as always, if you have any questions, feel free to email me. Have a great day.